Okay guys, welcome back to my YouTube channel, and in this video is going to be the continuation of the previous discussion. So for this Div.3 I started from E to D, so this will be the next video. If you want to watch it from D to E is okay. I don't think it matters anyway. So without further ado, let's just see the problem. So here's the problem. It's called come a little closer. So the game field is a matrix of size 10 to the power of 9 times 10 to the power of 9 with a cell at the intersection of the 8th row and the bth row column denoted as AB. Okay, so there are n monsters, so this will be the location, while other cells are empty. So you can move one monster to any cell on the field at most once. After that, you must select one rectangle. Okay, so let's see the example here. So the example here, we have this initial state, so like 1, 2, 3 here. We can move the 3 here so that we can choose this rectangle instead of this rectangle. Instead of 2 times 2, we can pick 3 times 1. So the initial value from 4 changes to 3. So this one also, it will be like 4 times 3, 12. If we move 1 into either 1, 4 or 3, 3, then it will be this rectangle. Okay, so the idea for this problem is that you just simply need to maintain maintain multiset to brute force and efficient deletion. So the idea would be something like for I from 1 to n, then later we want to erase the coordinate I, then later we check the answer, then we need to add again. So basically we just do it manually because you can only move one, right? So there's nothing wrong for us to basically brute force the answer from 1 to n, and we can use multiset for log n, deletion and addition, I mean insertion, sorry. Okay, so we have this. Okay, so the idea would be like, let's say we have this square, right? We have this square and this one particular monster, right? So let's label this as M. So we need to move the monster into this square. So basically we have like a bunch of monsters here. So basically we have predetermined this square in our answer later. So that is always optimal for us to, let's say we want to move this one, right? Move this monster. We just simply need to move it around this area, around where like the monsters are gathered. Okay, there's one edge case. So basically, let's say we have this, let's say I have like this one, right? It is full of monsters, right? But then there's this one outlier here. So what we need to do is basically we just pull it as near as possible to this square. But we need to make sure that we don't put it here. No. So we need to put it here so that the area will be smaller. So as you can notice that it is smaller for us to add 2 here instead of like adding here, then it will make like 4. Oops, why is it not? Okay, yeah. So this is not, oops, I forgot to move this. Okay, so this is not optimal. Yeah, so this is not optimal. So we just need to move this into 2, then we can add 2 later instead of adding 4. Okay, so let's just see my code here. So basically I put it to multiset and then I erase. So I use lower bound so that it only erases one element. Then later, if the size of x equals to 0, and the reason why I didn't check for the size of y equals to 0 is because x and y will always have the same size. Okay, then later, if the begin, okay, sorry, the n and the begin plus 1, and then like the begin, sorry, the n minus begin plus 1 is equals to n minus 1. So basically, let's say if we remove one monster, if there's a square that is packed with like monsters, something like this, here the 4 times 2 rectangle, so the answer will be this formula. So basically we add this size, and then later we need to find the minimum addition, whether we need to extend it vertically or horizontally. So the extension will be here in the minimum, then I just insert it back. Else, if it doesn't matter, we simply can assume that there's always a space, at least one space for us to take out this monster and put it. So something like this, there's always one space for us to move this monster into this rectangle. So the answer will be minimum of answer, basically the same as this without the addition. Okay. Okay, so yeah, so that's the okay, so that's all for this solution. I hope you enjoy my solution. Feel free to share and subscribe if you like this video, and I'll see you later. Bye bye.